OEE is powerful and useful. Take 0. All right, so in this video, I'm actually responding to a couple of comments on one of our YouTube videos on the video how to implement OEE in your manufacturing plant. This guy told me that the video was either the video or OEE is completely useless. And then there was a thread in LinkedIn today about OEE that I wanted to go over. So in this video, what I'm going to do, I'm going to go over those threads. I'm going to talk about OEE for a little bit, and then I'm going to go through a use case. So I'm actually going to show you, listen, OEE is fucking valuable if you use it correctly. And not only is it valuable, but you actually have to use it correctly. You have to implement it correctly. And I'm going to go over a case study and talk about some actual numbers and like why this fucking matters, and and hopefully put this to bed forever. Okay. So OEE is useful and powerful. It is. And if you want to see the comment that I'm using here, it's this guy Ahmed Farouk said that how to implement OEE in your manufacturing plant is absolutely useless. So he's either talking about our video, he either thinks that I'm fucking useless, or he thinks OEE is useless. But I think for the sake of this argument, we'll say that he's saying OEE is useless. So there was this other thread in LinkedIn. Rick Bellotta and I both commented on this. Actually happened today, where Dave McGowan posted, what is the most important metric to measure the success of a smart factory strategies? He said, according to this report from IoT Analytics, it's OEE. I completely disagree. But overall equipment effectiveness, which is the key metric to measuring success. Interestingly, the top 10 key metrics are made up of 8 operational measurements, which tells you that whoever put together this list is full of shit. That doesn't mean that operational metrics are not important. They absolutely are, but I mean, OEE is definitely not even in the top 5 in terms of KPIs for measuring the success of a smart factory strategy, which is what he said here. If it's improving IT-OT convergence, increasing the capability of IoT and connected devices, or the introduction of metaverse and digital twin solutions, what is clear is that the field of industrial automation is one where many exciting things are happening around tech solutions. I agree, but there. Okay. All right, so let's take a look. Rick Bellotta said the top item should most definitely not be OEE. Remove the OEE row and add a row regarding sustainability, energy, water, etc., and I can buy in. He actually started out with anybody with a brain knows that OEE is not the number one. He's actually a little more inflammatory to begin with. Chris Machinsky, who I don't know who that is, manufacturing intelligence at some company, he agrees that energy and sustainability initiatives become a key focus and driver. I disagree here. I'm going to talk about what it is I think it is in a second. Not that ESG isn't important, energy and sustainability is not important, but it's not the key driver of a smart factory. Okay. And then Dave McGowan put in his comments. Here's what I said. Okay. I said that I'm a huge fan of OEE as a concept and its use as a KPI for operational analysis when implemented correctly. But do I agree that it's the top metric for measuring the success of smart factory strategies? Not a chance. It's not even in the top 5. OEE, when implemented uniformly and correctly, does a great job as an entry point for root cause analysis and operational comparison of apples and oranges, so unlike processes. But it is a poor metric for smart factory strategy. The goal is a digital smart company that plugs into a digital supply chain, one that makes products that get better after the customer has them or buys them, from an organization where data is the primary commodity. You have to think bigger than OEE. Smart factory strategy is far more complex than just operational effectiveness. Okay. All right. So let me expand on this just a little bit, and then we'll talk about what is OEE, why is it powerful and useful. Okay. Let's start out with why. Let's start about at the beginning, which is, why does digital transformation even matter? Okay, like why do you want to become a smart factory, right? I mean, what's the reason you want to be smart? From a business perspective, it's to remain competitive. Technology exists today to make it so that instead of vertically integrating your organization, you're vertically integrating each individual business supply chain. So that is the inputs the raw materials, all of the inputs into a business and the supply chain to the outputs are all unified and connected digitally on one common infrastructure. Okay. And the technology exists to do that. And we have companies that do that. Amazon is an example of those companies. Tesla is an example. Tesla and, their partners like Saint-Gobain, they are connected through common infrastructure so that, Tesla understands, what is, driver side and passenger windows for the Model S. What is the inventory that my supplier has for me available for their just-in-time supply chain. The technology exists to be a smart company. That is a company whose primary commodity is data. Okay, so and Tesla is built on this. Tesla's concept is that we are not. Gigafactory is not to manufacture cars. It's to manufacture anything. Tesla is a data company that's created this infrastructure that is the model for how you could manufacture anything. Okay. And it goes into energy and sustainability as well, right? Gigafactory is designed to be microgrid, micro and macrogrid. Okay. So number one, the technology exists to be smart. Number two, your competitors are going to use that technology to get smart, which means they're going to be able to make decisions faster that will drive operational improvements, business improvements, and overall efficiency. And if you want to compete with them, you got to do it. Okay. So, the process of becoming a smart company takes some time, takes 3 to 5 years, right? So you have to connect all the smart digital stuff in your business. You got to collect all the data, every single event. You got to store every single event. Then you got to use some type of tool to analyze all the events, all the data. Okay. And then you're going to visualize that so people can, with their own eyes, look at patterns. Okay. Then you're going to use machine learning to look at that digital data to find patterns that you can't see with the naked eye. You're going to use artificial intelligence to consume the predictions from machine learning and make effective decisions. Okay. Then you're going to head off problems, which are going to make you more efficient. Part of that journey is putting in digital OEE, putting in a digital MES system. It's one of the first places that people start because if you look at the automation stack, okay, PLC HMI at the bottom, and then supervisor control and data acquisition in the second layer, and then you got MES in the middle, and then you got ERP, and then you got cloud. If you look at the ERP cloud, that's the IT sphere, and it's all digital, okay? You look at the PLC HMI and the supervisor control data acquisition layer, that's the OT sphere, and it's mostly digital, okay? Not all. It's certainly not nearly as mature as the IT sphere. And the MES layer in the center is nearly all paper. Very few organizations have digital MES systems. And one of the core four functionalities of a manufacturing execution system is the downtime tracking and the calculation of overall equipment effectiveness. And it is a absolutely critical component of your digital transformation journey. Now, is it the key? Is it the KPI? Is it the metric you should use to determine how effective your smart factory strategy is? Fuck no. I mean, that goes to that LinkedIn point. So, but it's a step you have to do. Well, we've shot videos on this. You must calculate OEE. You don't have a choice. And the reason why is this. It really boils down to this. Where did OEE come from? Right? It really started in the boardroom. Executives needed to know, as business was growing, do I have the capacity for this growth? So do I have the ability to, if I improve the efficiency of the way we operate with the existing resources we have, the existing manufacturing facilities and the assets we have, if I just make us better at using them, can I gain capacity so that I can take these widgets that I've sold and manufacture them? Or do I need to build new facilities? Okay. So overall equipment effectiveness is a calculation that was designed to determine capacity, along with its sister calculation, TEEP, where it's really simple. The TEEP calculation is designed to say how efficient are we relative to how efficient we could be if we ran 24 hours a day, 7 days a week, minus our minimum maintenance, maintenance to keep our facility running. Okay, so TEEP is how efficient are we relative to what we could do if we were running 24/7 minus our minimum maintenance. And overall equipment effectiveness is a sister calculation that says how efficient are our assets, how efficient are our machines and our equipment and the areas which those machines are in, how efficient are they relative to how to what it is when we've scheduled to run. So not if we ran 24/7, but when we're available to run. Okay, so let's say we're on a schedule where we run 40 hours a week. The OEE is against that 40 hours scheduled plan, whereas TEEP is against what would that number be if we ran 24/7. The TEEP number is always lower than the OEE number. 100, always. Okay, so what is OEE? It means overall equipment effectiveness, and it's a standardized efficiency calculation for production equipment. But because it's standardized, you can roll it up into ad hoc groupings. So you can take production equipment and you can group them into work centers, and you can take work centers and group them into areas. You can take areas and you can group them into sites. Okay, and you take sites and group them into enterprises. So you can take these OEE calculations and you can roll them up all the way to the boardroom. Okay, it takes into account the availability of equipment, the quality of the goods produced by that equipment, and the rate of production of the equipment to determine whether the equipment is operating effectively or not. OEE is a valuable calculation because it abstracts away the differences between equipment, leaving us with a KPI that can be used to contrast unlike equipment and processes in an apples-to-apples comparison. A really good example is I need a KPI that will allow me to compare this machine over here that all it does is has a blade that runs up and down and it creates pins at a certain length. And this machine over here that has a batch process and a quench process and a shot tempering process to produce links to make chain. I got the pins over here and I got the links over here. How do I know, how could I compare which machine is more efficient? It's producing more, it's running more reliably, and it's producing the highest quality products. How could I know which one's more efficient if I don't create a standardized KPI that applies to both and allows me to compare the two? That's what OEE does. Okay? So OEE is in a nutshell, availability times quality times performance on a scale of 0 to 100. So what we do is we calculate the availability of a piece of equipment on a scale of 0 to 100. Right? We calculate the quality of the goods produced that come out of that piece of equipment on a scale of 0 to 100. And then we calculate the performance of that machine when it's available and it's running, okay? When it's available and it's producing good stuff, okay? How fast are we producing relative to how fast we should be producing, okay? Availability is, in a nutshell, is the total uptime. That is how many seconds has this machine been available divided by the scheduled runtime. How long should it have been running? And it reveals maintenance issues. Quality is the total number of good parts, widgets, whatever, batches that come out of the thing divided by the total number produced. So that's good and bad added together. And then performance is the total parts produced divided by what we were scheduled to produce. And what this does is it takes into account when the machine wasn't available. We subtract when the machine wasn't available. So we have the total minutes of when it was available. And we multiply that by what the standard rate is. How many should it produce per second? And we multiply those two together. And that gives us what we should have produced. Then we take what we actually produced and we divide it by what we should have to get us a number between 0 and 100. Okay? We multiply the three together and we get OEE. Okay? So this is an example of availability being 56%. That means the machine was available 56% of the time. Performance was 85%. That means when we were running that when we were available and we were producing parts, we were producing at 85% the rate we should have been producing at. Okay? And quality, 99.88% of all the things we produced, when we produced, were good. That means they could be sold. They could be moved on to the next process. We multiply all three of those together to get an OEE number of 47%. So let's say I'm in the boardroom and I'm looking at capacity. Now, if I'm looking at an overall equipment effectiveness number of my organization or my business unit from the boardroom, what I'm looking at is a rolled up number from all the areas, all the assets, all the machines. But I can drill down. All I have to do is look at my boardroom number to see which of these three things is the lowest. In this case, it's availability. So now what I do is I drill down and I say, okay, which of the areas in my business have the lowest availability? Oh, it's this one over here. So then I drill down to that one and I go, which of the assets within the area in my business has the lowest availability? Oh, it's this asset. It's this cell on this production line. There's our downtime problem. That's our bottleneck. That's the thing we have to focus on. Okay? That's a simplified version of it. OEE is a really important number because it is the KPI that we use to do an apples to apples comparison between assets in our organization. How do I know which of my equipment is the most efficient? Now, there are a lot of people who argue that what you should really be doing is looking at profitability of equipment, which is ultimately where you have to get. But my argument is you can't determine profitability or potential profitability of a piece of equipment. That is, what are the operational costs to run that piece of equipment versus the revenue it generates, unless I know how efficient it's running. What's the efficiency number is how much I can gain by improving these problems. Okay? All right. Secondly, overall equipment effectiveness number is a number. OEE is a number that many business systems up and down the stack, when we talk about OT/IT convergence, need to know in order to focus their continuous improvement efforts. Not just in operations, okay, but in supply chain, in warehousing, in facilities management, all across the organization. Ostensibly, every group in your organization is serving production operations. So it's important for them to also know which of our operations are the most efficient, operationally speaking. Okay. All right. So let's talk about a use case. So this guy, remember this guy up above, told me that either our video is totally useless or OEE is totally useless. And a lot of people in this LinkedIn thread, are not big fans of OEE. All right. I am a huge fan of OEE when it's implemented correctly, but I'm certainly not a fan of it as a KPI to use as a metric to determine whether or not our smart factory strategy is effective. Okay. All right. So let's take a look at this use case. Okay. So this is an actual OEE implementation that we did at Intellic Integration. We did it maybe 6-7 years ago. Okay. For a manufacturer that produced one family of products coming out of these 5 production lines. So you had 3 sub-assemblies that fed into a assembly production line and then a testing line. Okay, so the last 2 production lines were basically the finished good. One was assembling the finished good, and then the other one was testing it to make sure, one final unit test to make sure it was good to be sold to the customer. Okay, they had been calculating OEE for the previous 5 years, and they were doing it on paper. They were implementing it incorrectly. There were a couple of issues with what they were doing. Okay, problem number 1 was that they really were only calculating QP, so the quality of the goods they were creating plus the performance of the machine when they were creating it. But they really weren't taking into account machine availability, okay? And they weren't categorizing their waste, okay? So they were calculating OEE on paper as quality times performance equals OEE. We see this all the time. We see this within organizations where they're using a different OEE calculation in multiple areas on different assets. Okay. Number 1, they were doing it on paper, that's a major problem. They were calculating it wrong. Okay. They weren't taking digital events off the equipment. Okay. Number 2, they were giving the operations team, the leadership group, the ability to fudge the numbers, that is, manipulate these numbers, and they had an incentive to manipulate those numbers up, okay, so that they would improve their production bonus. So they were getting paid a bonus each quarter if they hit their OEE target, which was 82%. Okay, so the company was paying the operations group a bonus if they hit their target of 82%. And guess what? They were always hitting that target of 82%. Because why? Because they controlled the acquisition of the data, the way they calculated it, and they could fudge the numbers. And how do they do that? Well, most of the time what they would do is they would rework products that were waste to get them to be good products, but they would never count them as waste on the first pass yield. So the first time it went through the machine, if it wasn't a good product, it failed, it became scrap. They never reported it as scrap as long as when it got reworked, it made it through. Also, they never dinged the performance. That is, if it takes me two passes to create one good part when it should only take me one pass, that means that my performance on that part's 50%. They were giving themselves credit 100% because they weren't dinging themselves for the second pass. So what we did was we were approached by an engineer who had about $250,000 left in a budget, and he said, "Could you put a digital MES system on this in this area for $250,000?" And I said, "No, I can't. It'll be maybe $500,000. This is a lot of work here. It's going to take us, 6 to 9 months. It's probably going to cost $500,000. But I'll tell you what I'll do. We'll do it for $250,000. I'll pay the other half of it. I'll eat it. Okay? But you have to give me absolute control over what is produced. And so you can give me requests, that is features that you would like to see. Track and trace was one of them, right? That kind of thing. But you let me build it. Let us and our team build it what we think is most effective. So for the $250,000 that we're going to pay in this project, you let us build our thing." He said, "Deal." Okay. So we did one area, okay, which we made a family of products, had 5 production lines, 3 production lines that had sub-assemblies that fed into a assembly line that fed into an inspection machine. It had 47 machines, so I had 47 PLCs, had one family of products. It took us a year to do the integration, the total integration, and I'm not showing you everything here. I'm showing you about a quarter of it, the stuff that I can share, okay? There was a 3-month IT delay because there was a bunch of networking stuff that had to be done on the machines, network address translation, setting up all the controllers for UDP, all this kind of stuff. And then the integration steps were this. We did a digital strategy. We created enterprise architecture design, network infrastructure we had to put in. Then we did the SmartThing connectivity that connected all the PLCs. We did our homogeneous MES integration. That is if we're going to take this and scale it to all the other places in the business, we did the part that would look exactly the same no matter where we went. Then we went heterogeneous. That is the unique features for just this area. We did our unit testing, production testing, and then we trained the operators the operators and engineers on how to use these screens. And then we did data collection. We basically collected data on OEE. We taught them how to use this. We collected data on OEE, on waste, and on production. And we analyzed it at the 90-day, the 6-month, and the 18-month interval. And then we calculated ROI. And here were the results. All right. So number one, we gave them this run overview screen. Okay, I've had to block out any of the stuff that's protected by a non-disclosure agreement. All right. But what we're looking at is a standard OEE screen that's got overall equipment effectiveness. We got availability. We've got performance. We've got quality, calculating OEE at 86%. Lower left-hand corner, we have run chart, production, downtime, Pareto, all that kind of stuff. We have all the individual downtime events in the lower right-hand corner. We have the downtime events for the individual cells that make up this production line. We had a couple of analysis screens, based on shift utilization, overall equipment effectiveness, things like utilized time, unutilized time, etc. We gave them, this is a really valuable screen for them, which was top causes of downtime by reason, top causes of downtime by cell, okay? And then we gave them this overview screen, which basically allowed them to look at, this is a production screen. The top screen here is when was this production line scheduled to run? So green is when it should be running. Blue is when it was scheduled not to run. Okay. And then the second line here is the production line entity. So when was it down? Red means it was down for unplanned reasons. Okay. And then this is all the individual cells when they were down. And one of the things that we had to ascertain is, okay, when is the production line down? Okay. A cell could be down in that production line. That doesn't necessarily mean the line itself, the production line itself is down. Okay. We gave them top 5 line downtime reasons, cell details, hourly production, scheduled versus actual versus target production, and then defects by cell. That is when a product went bad, why did it go bad by cell? And then here are the results. Okay, so $250,000 spend, 1 year work. The first thing we did was we calculated OEE for the whole production area. Okay, so OEE for the whole production area. When we launched, this is in January of the first year, the OEE for the entire area was in the low 40s, which is very, very common, by the way, 43%. So that is all 5 production lines equaled 43% OEE. On paper, they were calculating it in the low 80s. So the first thing we had to do was we had to prove to their operations group, by the way, they were pissed to see this number, very common. They were pissed to see this number. We had to prove that this number was right. Okay? Once we proved that that number was right, they started using the system to analyze what the actual issues were by those 3 areas: availability, quality, and performance. Okay? And it took them 60 days to get the OEE number into the upper 60s. It took them 6 months to touch 80%, and then they held that 80% for 12 months. Okay, so nearly doubling overall equipment effectiveness for the entire area across 5 production lines. Okay? The worst performing production line, okay, by month was operating at 27% OEE. Took them 60 days to get that number into the mid 60s. Took them 6 months to get to about 70. They peaked right around 73% in the first 9 months, and then they held that for a year on the worst performing production line. They were generating 3,500 units of waste per month when they first started. They peaked at 4,600 units of waste, it looks like in the 4th month. And then they gradually decreased their waste over time, where in the last month, they were producing about 600 units of waste the entire month for the area. Okay, so from 3,300 units down to 600 units. And for production, they were producing about 35,000 units in the first month. Within 4 months, they got that into the upper 40s, 48,000 units. Within 6 months, they were at 65,000 units. And it took them about a year to get to 74,000 units per month of production. Okay, so in 18 months, they doubled their overall equipment effectiveness. They reduced their waste from 3,700 units down to 600. They increased their production from 36,000 units to 74,000. Okay? Total yield on a $250,000 investment, which should have been $500,000, $25 million. So, to my friend, to that which they used to fund their entire North American digital transformation initiative. So, to my friend Ahmed Farouk, and to all the non-believers of overall equipment effectiveness, OEE does in fact work when it is implemented correctly. Do I agree that it's the top metric for measuring the success of smart factory strategies? No, I do not. Okay? But when it is implemented uniformly and correctly, and it does a great job as an entry point for root cause analysis and operational comparison of apples and oranges, those unlike processes, but it is a very poor metric for smart factory strategy. OEE, there are so many haters out there on OEE, and I can tell you this, I've been doing this a long time. Nearly every organization in their digital transformation journey is starting with some type of digital MES after they have digital strategy architecture minimum technical requirements, because that's where IT-OT convergence is taking place. the place where you're converting a sales order into a manufacturing order. The most organizations are completely blind to why it is they are not performing operationally. And until you put in a digital MES system that is picking up the rising edge and falling edge of all of these key events, and you're calculating the availability of your equipment accurately, you're calculating the quality of the goods that you produce accurately, and you're calculating the performance of your equipment when it's running accurately, and you're using a common standardized KPI, you are fucking blind. Okay? So, that's probably the last time I'm going to do something like that on OEE. I wanted to make sure that I drove home the point here that OEE is valuable and it is useful. But the reason that so many people are disenchanted with overall equipment effectiveness is because it's being implemented wrong. You're using the wrong calculations. You're picking up the rising and falling edge of the events incorrectly. You're not defining when a production line is down correctly. It's not absolute across systems, okay? Uniformity and standardization is incredibly important. Not the least of which is giving, people who work on the plant floor the tools they need to effectively analyze that data and get down to a problem and be able to solve it. I would love to be able to list out what it is they actually determined the issues were. I'll give you a hint. It was microstops. Okay. Microstops were the fundamental issue. Okay. There were some key engineering problems with some of the robots they were using to do some welds and that kind of thing, which that is what reduced their waste. Okay. Reduced their need to do second passes. But the key issue was microstops. Okay. All right. Hopefully that was valuable. All the stuff, like, subscribe, comment down below, click the bell. Let me know whether or not this was a valuable video, whether you want to see something more like this style of production, okay? And I will see you in the next one.